Good afternoon, everyone, or morning or evening, wherever you happen to be. This is the OpenEdX Community Online Meetup, October 8th, 2020. I'll get a few bookkeeping things out of the way. The OpenEdX community has a number of resources for you. All of our interactions, whether online or someday in person, are governed by our code of conduct, which you can read on the OpenEdX website. We have a discourse forum for discussions, which is great because you don't have to be in the same time zone as people. You can take your time reading and composing responses. We're using it to good effect for the build test release working group, which I'll be mentioning in a few moments. And we have a Slack workspace, which you can join to have synchronous chats with people. It works great if you have a focused question and you need to get some help, or if you're working with a disparate group of people that are spread out around the world but still need to chat together. Of course, we're on social media. We have a blog, we have Twitter, we have Facebook, we have LinkedIn, all under the word OpenEdX where possible. These online meetups happen once a month or so. We missed September, but we're back again for October. If you'd like to present, please get in touch. You can send me an email as OSCM, Open Source Community Manager, at edX.org. We also have a Google form where you can simply submit an idea of something that you would like to tell the community. Get word out there about something you're working on, some site you've created, some kind of instructional design or delivery that you think is interesting for people. We've had a whole range of talks from very technical to much more sort of educator focused than technologist focused. So we're interested in what you have to say. If people using OpenEdX would be interested, then we are interested and we want to give you a space to tell people what you're doing. I mentioned the working groups. We have a few going right now. The build test release working group is working towards owning the community installation of OpenEdX, working through issues with how it gets produced, the technology it's built on, and we're working towards COA, which is going to be released in the beginning of December. That's the next community release. The marketing working group is talking about how to tell the world about OpenEdX, how we can band together both as edX and as service providers to let people know what we're doing and how great the OpenEdX project is and how people can get involved. If you want to join either of those working groups, or if you have an idea for another type of effort that community people could come together to push forward, join the working groups category in discourse. There's a link there. Discourse is discuss.openedx.org. And let's talk about it. Let's get things going. Brand new, I may have overdone it with the clip art on this page. It's not our usual style. Brand new on the open.edx.org website is a dynamic list of features. It's a benefits matrix of all the capabilities of the OpenEdX platform. It's a dynamic table that you can filter by what you're interested in. If you're trying to convince someone to use the OpenEdX software and you want to give them a resource so that they can think about it, this is a new element of our website that could help with pushing someone over the line to seeing that OpenEdX is the kind of software they would like to be using. So give that page a look. It's not set in stone. If you think there are things missing from there or things that could be improved, get in touch. We can update that page to make it as compelling a resource as we can. Are there any questions about anything I have said, any of that introduction material? Any comments or thoughts from people about that before we get started with the main content? Give you a second to respond. No. Okay. So I'm very excited to hear from Andrés González from Aulasneo. They have built a new analytics tool for OpenEdX sites. And people often are really interested in analytics tools. The tool that edX provides is for very large sites, and it is not always done what people need, and people have innovated in a few different ways with analytics, and Panorama is the latest entrant onto the field. And so we're going to turn it over to Andrés to tell us about it. So I will stop sharing. And now Andrés can take over.
Okay.
And if you have questions during the presentation, put them in chat. And we will try to weave them into the flow of the discussion.
Okay, thank you, No, thank you, everybody, for joining here. Can you hear me and can you see the screen?
Yes, and yes.
Yes, perfectly. Well, okay, thank you very much. Let me first introduce ourselves. We are Aulasneo. My colleague Esteban Echevarri is here with us, and me. We are making Aulasneo. We are offering Open edX as a service to the world. And now we created Panorama, it's an analytics software, analytics system. And I will show you a very general overview so that you don't see this screenshot, but it's this analytics software has everything it has to do. It has pie charts, gauge, those timelines, lists, heat charts, and all the information that you may be interested in seeing here from an Open edX, enrollment, students, how many courses, video scenes, and all this stuff. So what makes it different from other initiatives is that we are using a serverless approach. And well, everybody's asking me when we started talking about Panorama, how complex is the code, how much lines, how is it made, how difficult it is. Well, and I always say, well, there is no code here. And actually, it is almost no code here. And I will show you how we achieve this. But before, sorry, it is our new baby, so we love it. We really think it is the best. But we really think it is better than other approaches. It is, of course, compared with traditional web applications done in procedural languages, in Python or whatever. And we have achieved a system that is really faster to implement. It can be added in a few minutes. It is simpler because one thing that we wanted is we didn't want to make any change in the code base of Open edX. There is no application to install, nothing to install in the server, nothing to install in the client. So it is very simple. It is really scalable. And the idea is that this system can go beyond the course and go beyond the Open edX instance. Sorry for that, I like big bets, but I dare to say that potentially all the Open edX instances in the world and even edX itself could be analyzed from a single installation of Panorama. It's too much. I don't really know if it's going to happen ever. But at least the idea of the design is that we can make something that is really scalable and that we can collect multiple instances in one single analytic system. It is very, very flexible because it can easily integrate with other external data sources, not only the information sources from the Open edX instances. It's very controllable because you can control exactly which user access each data. So you can give access to administrators, to teachers, even to students, and control exactly what they can see. It is very customizable because you can give the end user even the ability to create their own reports and their own analysis. There is something that we would like to explore, that is start using machine learning to augment data. These algorithms can take all this information and, well, apply those machine learning algorithms to infer additional information. It is almost independent of OpenEDX releases, so even if OpenEDX goes to another release and then many upgrades, they most probably will not impact in how Panorama is working. It is very safe because we didn't want to open any port to extract the data, and we didn't want to use APIs for data extraction. Then you will see how we do extraction of data. It is very secure because we can benefit from IAM, that is the Amazon platform for identity access management. It can offer multi-factor authentication and security controls very, very, very advanced. It's very reliable because as it is based on serverless architecture, there are no servers, there are no operating systems, so there is nothing, at least in terms of infrastructure, that can fail. It is very efficient because it doesn't load heavily the instances to load data or to processors to show data. It is also easier to maintain because as there are no operating system, there are no dependencies, there is no infrastructure, so there are no packages that break or software that gets updated and you have to update dependencies. So it is very easy to maintain. And it is even cheaper because if you have a web app application for analytics, well, at least you must have one or several instances, EC2 instances. And here the model is that you pay as you use. So if you use more, of course, you're going to pay more, but if you use less, you're going to pay less. So I think that at the end of the day, it is cheaper than any other traditional approach. So let me show you. So here is a basic and a big picture, a big diagram of the architecture behind Panorama. I will go in detail of the different parts later, but first I would like to stress, as I said, as you can see, there are no EC2 instances here, of course, except of those in the left that are the OpenEDX instances, but there is no virtual machines here. And also there is no relational database. So this is the big picture, and I will show you how we do this in detail. So first thing, how to get data from the OpenEDX instances. Well, we have a few design principles that we wanted to follow. Well, first was we didn't want to touch the code base. We didn't want to make any change in the OpenEDX code to make it work. Also, we didn't want to load the CPU or to disturb in any way the OpenEDX instance with data processing or data extraction or running any additional application. We are not installing an additional Django app for Panorama to work. And we also didn't want to use existing APIs and neither to open database ports. So how do we do it then? We had a lot of discussions, and sorry if it sounds a bit rudimentary, but we found a really efficient way of extracting data from the databases. That is basically dumping the data into CSV files. We have three main sources of information in each OpenEDX instance. First, One is the MySQL database, where we have the structured student course data or structured information. Then we have MongoDB. We're not using a lot from MongoDB, only from the module store we take the display name of the different blocks, because in the rest of the information, the place in the course is referred as the block ID, and the block ID is not very user friendly. So we are taking from MongoDB the basic structure and getting the section, subsection, unit name for each block ID. And another big source of information are the tracking logs. You know, there is an app, the tracking app, that records every little thing that happens in Open edX, records a row with a JSON format of data, depends on which event. So these are the three main sources of information. And as I said, we wanted to keep it very simple and very lightweight to the instance. So what are we doing? We're putting in a cron job a very simple script. And what it does is just take a selection. I think in our last version, we are taking data only from 10 tables of MySQL. And we are just running a simple query that is select asterisk from the list of 10 tables, and dump all this data into a CSV file. Very simple, very lightweight, and there are no joins, no filters, no data calculations, no data aggregations, nothing. Just dumping the whole table down to a CSV file. For MongoDB, it's something similar, but we are not dumping Mongo, because dumping Mongo is a hard job, but we are reusing a manage command and extracting only the data that we use. And the tracking log, there's nothing to do, because the tracking app just stores all the logs in a directory. We just take this and upload. So this is the way that we found. It's the most simple, effective, and efficient way to extract data from the Open edX instances. Okay. So now we have all those files, text files or compressed files. And what do? We put it in S3 buckets. What are design principles here again? We want to keep data as pure as possible, as close to the end user as we can. Why do we do that? Because we want to leave as much raw data to the end user, so the end user can have the freedom to make their own calculations, their own data aggregations, and their own data science at the end. Okay. So what we're doing, the CSV files from the MySQL and from the MongoDB, we're uploading to an S3 bucket. And the tracking logs, we are uploading to an S3 bucket. And here we have to write a very, very small Lambda function that it doesn't process data. It only corrects, because there are some records in those tracking logs that are not well formed, so we have to fix some format. But this is the only thing that we need to write in Python. Here it is just reformatting those JSON compressed files to so that the next steps can take these files without any problem. Okay. So next step, data extraction and transformation. So now we have the tracking logs processed and healthy tracking log files in another bucket. Then we have all the MySQL dumps. Actually, it's all in the same bucket, but in different folders. So we have all the MySQL, it's around 10 tables from MySQL, 10 CSV files. And then one additional table with the structure, the module store from MongoDB. What do we do then? Then we inject all these files, all these directories in S3 into an AWS service called Glue. Glue is a very interesting service. It has two main components that are the crawlers, and we will see later the jobs. What do? They are triggered based on fixed schedules that can be configured, even can be configured for the different services. And they transform all these plain text or CSV files or compressed files into something that the next steps can take and can process. Okay, and at in this point, it is very interesting that we can implement. We haven't done it yet, but it's something that we want to investigate. We can implement here machine learning algorithms. So, next steps. You may be wondering, as I said, we do not have a relational database. So, where do we store all the data to be queried by the analytics engine later? We are not using a database. We're using a concept of data lake. If you're not familiar with the concept of data lake, you can think of it as something similar, not exactly the same as a data warehouse, but with some particularities. First, this data lake is fully stored in S3. Another difference, we are using a format called Parquet that is prepared to manage very huge data sets. It runs Hadoop and technologies like Apache Spark, Hive under the hood that is prepared to process teras and petabytes of information. So it can really scale virtually without limit. It allows semi-structured information. Well, the data from the MySQL is quite structured, but the data from the tracking logs is not exactly. So Parquet format allows us to process all this information that is not exactly structured. And another benefit that we are using is the possibility to partition data. And well, the concept of partition is also available in relational databases, but basically what is a partition database is a database where the engine can quickly find the place where to query data based on the value of one or more columns or fields, okay? For instance, how are we partitioning all this data? We are currently using two criteria. One is the LMS. As I said, and if you let me go back to the first slide, I put here only two edX instances, but I can grow here and put as many instances as I want. And even I can include instances from other AWS accounts. If I get each one of these instances, put this information into a bucket, and I can get that information into here, I can collect the information from multiple instances into one single analytics engine. And what we are doing, as we are partitioning all data, and one of the partition criteria is the ELMS URL where this data comes from, it allows us to have a very scalable and very efficient way of storing data. If I add an additional OpenEDX instance here, this will not impact the performance. Why? Because I will be querying only the LMS where the data I am interested in is, okay? And another important partition we are doing is based on date, because the tracking logs are quite huge. You can have billions of records in instances that have a quite activity. So when you're looking for information that is in the tracking logs, it is better to partition because, for instance, if you are going to audit, you don't want to know what happened 3 years ago. But if you want to take a report, maybe you want to know only what happened in the last month or in the last 2 months. So partitioning on year, month, and date allows to grow along the time without impacting database performance. So we can grow on time and we can grow in sources of information. There is a component here that is the data catalog. As I said, that the AWS service has, the AWS Glue service has 2 components, the crawlers. The crawlers, what they do is inspect all these buckets for a schema. They try to infer the schema, and also they create the new partitions. Every day, when we have a new set of tracking logs, well, the crawler creates the new partition for the new day. And if we add a new LMS to the system, the crawler will find it and will create a new partition for that additional LMS. Okay, and it's always all this information, all this schema and partition information is stored in a special database called data catalog that is used later by the queries engine that I will show you in the next step, in order to go and fetch the actual data. And the other component of the Glue service that is the jobs, those what they do is take all these plain text files, all these compressed tracking logs in JSON format, and they convert into Parquet format and put it into another bucket that will form this data lake where all the information is stored. Okay. Okay, that was the difficult part of the system. Now there is another service in AWS called Athena, and the basic function of Athena is implement a database query engine. You can write a standard SQL script here in Athena, and you can query and you can join all the fields that you want. You can make calculations, you can join tables, left, inner, right joins. You can do a lot of things. It uses an engine called Presto that is very, very powerful. So you can write really complex queries here. But we do not want to analyze data here. Well, the function here within Panorama is to prepare data for the later steps, okay? But this is Athena is necessary because you cannot go and write a SQL query to look for something stored in S3. So you need Athena to query S3 information in the data lake using a standard SQL language. And here we come to the last part. The last part is actually the analytics engine where all the calculation is made. This is why we wanted to keep data as pure as possible until here, so that the end user has all the freedom to make their own analytics, their own data science. Well, the front end is based on another AWS service that is called QuickSight. Well, we haven't programmed, so all the benefits of QuickSight, you can go in Amazon and investigate. It is really, really nice what they've done. And one very, very interesting feature is that QuickSight includes a service called Spice. What does Spice do? You prepared your queries, okay? So you define your data sources, right? For example, one data source for the student information, another data source for the enrollment information, another data source for the event tracking, and Spice makes all the queries via Athena and brings the results into memory, into server memory. And then all the calculation is done in memory. And in Spice, and this is something you can give to the end user if you want, of course, or not if you don't. You can give the end user permission to create your own data sets, your own data sources, so you can here again join additional tables, filter, calculate, and everything you can do again using SQL standard language. That is very, very powerful. Additional benefit is that here in QuickSight, you can also add external data sources. For example, if you I don't know, you have an administrative database, or I don't know, if you want to take data from Salesforce or from Jira, from whatever that you can query with a standard driver, you can bring all this information. And if you use, for example, if you bring a table that indexes by user email or by the course ID, then you can join those tables with the information coming from the instances, and you can create additional analysis with external information. Also, another benefit, well, the dashboards, I will show you how it works within QuickSight, but the dashboard can also be embedded in external sites. And very, very interesting feature is that you can apply what they call row level security and column level security. It means that you can take one user and define exactly what this user can see based on the content of the field that you want to define. For example, the administrator of one school may be allowed to see only the information related to that organization. But if you want to give access to a teacher, you may give this teacher access only to those courses where he's part of the staff. Or you can even give access to a student and let him see only those events and all those information that relate to this user exclusively. Okay. So, well, basically, this is how Panorama works. Let me show you a real implementation. This is not a test environment. This is production. What we are doing here, I am logging in with a test user, and this test user implements this row level security that allows me to see only those demo data. Okay, so what we are going to see here is demo information, but it is running on the production service. Basically, what you have in your main screen, you have all the dashboards that the administrator shared with you, and I will show you a few of these dashboards. For example, here you can see this donut graph that shows how many enrollments do you have in your organization that are currently active. This is the total, and the color is for the course code. Okay. Then here you have users. We have more. This 132 is because it is enrollment, and as one user can be enrolled in more than one course, you have more enrollments than users. How many enrollments have been detected? Never. People that enroll but never access the course. Here in purple is enrollments accessed in the last 30 days. Or in light blue, people that access the system sometime, but more than 30 days ago. And a lot of things that you want, you can do whatever you want here. Distribution of grade, how many people approved, how many people downloaded the certificate. This is a timeline, how many people enrolled in the courses by month. Of course, lists, you can take a list with the detail, and you can also export to Excel or to a CSV, a heat map with size and color, showing different values, more and more details. This is a basic dashboard for enrollment. I have one here for course staff. It will show all the courses here. We have the courses, the status of the enrollment of the courses, and the date, if the course has started or not, dates, information. And well, the thing is that you can also click on different parts, and you can filter. For example, if you want to see who are these guys that never went to any course, you click on it, you find that they were 34 people in 43 enrollments enrolled in these dates, and here you will be able to see in which courses and which person did not attend, never. Here I have to fake some emails to hide real people information, but here you can see who is the people that never, when the course started and when they enrolled, but they never joined the course, and so on. Another very interesting thing, because this dashboard is based on information that is in the MySQL database, that is the enrollment tables and user tables and so on. But here we have another dashboard that is based on the tracking logs. And I wanted to see here which are the videos that are most seen. And here I have a heat map that is mapping where usually I would have the email of the student here, but I have to hide it now. But here you can click on any one. For instance, I want to see, okay, this box is a video that was seen by a person only on a 17%. So there is somebody here who didn't finish this video. So if I click here, I can then see below from which course this video is. So I have here, and this is what I told you, I take from the module store, the name of the chapter, the name of the section, subsection, unit, and so on. And here I see that this person only saw the 17% of this video. And here I can see the detail of everything, every event that this person did with this video, this date and time when loaded video, pause video, play video, stop video, and so on. So all this information can be visualized by the students, the teachers or administrators, whoever you give access to. And well, something very funny I wanted to do here. I have a map of IP addresses and devices from which the student access, because sometimes I want to check if somebody is given his credentials to somebody else. So if I see too many IPs and too many different devices, I can detect this kind of thing. So this kind of graphic can help me. And I have an external option here that I maybe taking from the IP, I can see this student, which is the ISP provider and approximate location where he was accessing the platform. So these are only a few things that you can do, but of course there are many more things that can be done.
We have
here.
some questions in the chat. I want to make sure we have time to get to also.
Okay, so I am just finishing.
Okay.
Just the last words are, okay, how can you contribute here with this project? I have created only a few dashboards, but of course, if you know, I would like to have everything that can be seen in Insights or other analytics to mimic other systems and have all the same information. Of course, an overall optimization would be needed at some time. For example, improving data ingestion of the tracking events or some parts, how to get information and process information. Something that we want to do is embed these visuals in third-party sites in order not to have to get into this quick site. Create new transformations and use machine learning. So if somebody is expert in data science, I think that a lot of benefit can be taken from here. And well, the last point, because a lot of people is asking me under which license is going to be published. Well, we want to publish as a GPL license. But I will say there is no code, so what can we share? But well, there is a service in Amazon called CloudFormation that you can write a YAML file describing all those components and how those components are linked together. And when you apply it, well, this should create all this infrastructure. Well, this is something that could be published, so everybody can also download and also contribute here. So help in creating these CloudFormation scripts is something that you can also contribute. And well, I don't know what time is it. I don't want to extend a lot. So if you have any questions, any comments.
Yeah, so there are a few that are in chat already. Two are about the size. So Pierre asked about whether you're only handling active courses or because 6 years of tracking logs is a lot to handle. You can, yeah.
If I can add on this, Ned, it's more like, I don't know how many times they try to update the tracking logs, because if they try to recover them or get them each time, it will be a big size. So I hope that you can, a little bit like Insights, that you can push your tracking logs to a bucket and then they take it from a bucket instead of directly from the system.
Yes, well, you know, the tracking logs are incremental. So when we are pushing from the instance to the buckets, we are only pushing the new logs that are created. Okay, so the first time, of course, you have to push all that you want. So the first step will, if you have 6 years of tracking logs, okay, but probably you already have in an S3 bucket. So it will be just a matter, yes, of giving access to that bucket, and that's it. What is really impacting is the pre-processing. There's something I have to investigate also, because when I process the logs every day, I recompute all the logs. But I think there is something I have to investigate there, that I can compute only the incremental logs, because all logs never change. So and maybe also this strategy of partitioning the database by year and by month allows you that if you want to see, okay, taken statistics of everything that happened in since the very beginning, okay, you can do it, and you can get all the logs from the beginning, okay? But normally you will not have to do this. You normally want to see the logs of the last month, or the last 2 months, or the last year. Okay?
Not necessarily. I would give an example. Let's say you've got a course in in the summer semester, and then you've got a course in the winter semester. Sometimes you want to compare the data on both courses.
Yeah, sure. Definitely you can. Definitely you can. The only limitation here is SPICE, because you would need to bring all the tracking log information into SPICE, and SPICE has a limit. It is not a hard limit, but if you want more limit, you have to pay. So if you want to to keep down costs, okay, what you can do is first see if you need all the information from the tracking. The tracking logs are not very heavy because they are a lot, but information is light because it's text files, and they are not very bad. So we tested in our tests. We had 10 million records, and with 10 million records of logs, we did it in, I think, in 15 gigs of SPICE without having to purchase any additional space. So it shouldn't be a problem.
Another of the questions is about how real-time this could be made if you had an open edX system with 1 million users.
Okay, now currently in our test we are only refreshing data once a day. It could be refreshed once an hour, once a minute, or whatever. Why? Because for example, the Athena, every time, how Athena works, it is not like MySQL where you have the engine installed in a server. Every time you need to make a query, Athena starts a containerized application. I'm not expert on the details how they do this, but they start the service and they do and they implement all those MapReduce techniques, and they use Hive, and they use Apache Spark, all those techniques that are very quick to process huge amounts of data. And as the data is partitioned, so you can add millions of user information, and then it will scale up as your need, as you really are querying data. Okay.
Good. The last two questions are focused on AWS. One of them is about GDPR and the death of Privacy Shield. I don't know the details of that, but it's in the chat if you want to read it. So the question is, does Panorama reliably scrub personally identifiable information at extraction time before uploading to S3? And it sounds like,
okay,
based on the fact that you had those email addresses on the screen there, even though they were demo email addresses, that it does not, that if they were real email addresses, they would be at Amazon. Is that right?
Well, yes, but at least the open edX databases are also in Amazon.
Right.
So everything is there. So, but for sure, there are some things that must be taken into account. What needs to be done here is first protect data, stored data. S3 should be encrypted, and the keys should be protected, and also data in transit should be encrypted. And the another layer of security is how do you grant users access to those information. You know, in Amazon with IAM, you can limit user access at different levels. So if you have somebody that shouldn't be even accessing S3 by any way, okay, so you can limit access to that user, to that group of users, or you can grant users or group of users to selected portions of data, records, fields, or even S3 buckets.
Okay. I don't know if, so I'm reading these questions and I don't know if people want to follow up to get at more detail on particular aspects of it. One last point made here in the chat was that QuickSight, the costing model, is a big concern for a large user base. Sounds like it's expensive. Is that right?
It can be expensive if you want to give access to every user. I think a read user is $5 a month.
This is users of the data dashboard.
Yes,
not number of students. I see.
Yes, if you want to give all your students, of course, you will have to consider $5 additional for each one of them.
No, I misunderstood what user referred to in the question.
Yes, another option would be not to use QuickSight, because we are using QuickSight as the end analytics, but you can also take data from Athena, from the previous point, the previous step, and then you can skip. Of course, you will not benefit of the QuickSight features, but you can query those data, maybe selected data that you want to make available to a big mass of students.
Yeah, so sorry. Actually, I asked the question, the costing one. So basically, if we want to give it to the admin and they want to do a whole analytics on the courses, that is pretty nice. The QuickSight is pretty nice. But if you want to give the access to each and every student, then it comes to the costing is really huge concerns.
Sure, but
for a limited set, it is really good.
Would people want to give their students access to analytics dashboard like this? Maybe I don't understand how people are using these things.
So the only thing is like the progress. If I say the existing progress is something, if you want to give a nice look progress to the student, it is really a good things for the student.
I see.
But I guess you cannot achieve based on the QuickSight.
Yes, what you can do. Let me share again my screen. Oh, sorry, I can.
Yeah, hold on one sec. So while we're getting this screen ready, we're getting close to the end of time. So I want to make sure we also cover how people can. In fact, maybe we should just switch to that. So how can people find out more about this? I know that there's a thread going already in discuss.openedx.org.
Yes.
I personally am interested to know how I can get it, since you keep saying there's nothing there, there's no code. So I'm wondering what I can get to do this myself. I'm kind of not seeing how the pieces all come together. So I'll want to find out more about that. What else can people do to find out more about Panorama?
Okay, I really love to have a working group of people who is interested in helping, because if you want to, as you said, what we have, I have a receipt of how to make it, but this is not a step-by-step approach of what we need to share. But I would really like if there is somebody who wants to contribute, for instance, doing this CloudFormation script, then we can have something to publish, and that can unlock contribution from other people, right?
Okay.
So I think everybody can write to the discuss post, and then we can answer there.
Okay. I will put into chat here. I don't have the.
I think Esteban already.
Did he put it in? I also lost my chat window, so I can't find it.
Esteban already posted it.
There it is. Okay. At the end of the chat there, Esteban put in the link to the introduction to Panorama thread and discuss. Go there, talk about this, see how you can participate, use it, find out more details. Of course, discuss. Thank you, Andrés. Thank you very much. This has been a great presentation. Every time I do one of these, I am personally excited to find out even more about what the person has just told me about. So thank you so much for coming to do this.
Thank you.
I'll remind everyone, if you have something that you would like to share, something to talk about, get in touch. Our next event is November 12th. We have a speaker for November 12th, but we'll be having a December event. That will be the Celebrate Koa release meetup. But if you'd like to be the speaker for that, get in touch. and I will see you in Discourse and in Slack. Thanks for coming.